How to prevent thermal runaway in electronics cooling. Have you ever wondered what happens when electronics get too hot? It is a serious issue known as thermal runaway. This can lead to component failure or even fires. Let's look at how we can prevent this from happening in electronics cooling. First, effective heat management is key. You can use active cooling methods like fans or liquid cooling systems to remove heat from high-power components. For example, liquid cooling loops are great for keeping temperatures stable, especially under heavy loads. Heat sinks also play a vital role in dissipating heat efficiently. Next, passive cooling techniques can help too. This includes designing for natural convection and using thermal conduction paths. Heat spreaders can also reduce hotspots, which are areas that get excessively hot. Another important step is to incorporate thermal insulation materials. Materials like aerogels or fire-resistant foams can be placed between cells or modules. This helps prevent heat transfer and stops thermal propagation within battery packs or electronic assemblies. Now, let's talk about thermal barriers and physical separation. Designing battery packs with thermal barriers can slow down heat transfer. This helps contain any thermal events to a limited area. Using materials that resist heat and do not ignite easily is also beneficial. Monitoring and control systems are essential. Integrating temperature sensors throughout critical components allows for real-time monitoring. Battery management systems can track temperature, current, and voltage. They provide alerts or trigger protective actions if thresholds are exceeded. Additionally, using current limiters and fuses can shut down or limit electrical flow during abnormal conditions. This prevents overheating and keeps everything safe. Safety reinforcement layers are another effective strategy. Positive temperature coefficient materials can be used within battery cells. These materials reduce conductivity or interrupt current flow during abnormal temperature rises, stopping thermal runaway at its source. Containment systems are also vital. They isolate affected cells or modules to prevent fire or heat from spreading. Fire protection pads or coatings can minimize heating and burn-through of casings. Lastly, rapid cooling techniques can be employed. Immersion cooling is one advanced method that can maintain cooling even during thermal events. However, it does present engineering challenges for widespread use. In practical applications, these principles are crucial for electric vehicle battery packs and power electronics in industrial machinery. Mechanical engineers must balance effective heat removal with safety features. By combining passive and active cooling with robust monitoring and containment strategies, we can effectively prevent thermal runaway in electronics cooling.